OK, let me give you some examples of integer overflows that actually occurred in real life. So here's an article from 2004. And basically, there was some voting machine, and the voting machine was producing very weird behavior. So somehow the computer had a glitch, and the glitch caused the amendment to fail, even though it actually passed, or something like that. But the key line from the mayor of this town is, the software is not geared to count more than 32,000 votes. So when it gets to 32,000, the software starts counting backward. That's what the mayor said. And when I look at this from a computer scientist standpoint, I see the number 32,000, and I think that's pretty close to a power of 2. So maybe what the mayor was trying to say is the voting machine reached this maximum number, 32,768. That's the largest number you can represent with 16 bits. And then when you add 1 to that, you get negative 32,000 something, and then you continue counting, and in the negative numbers you start counting up. Maybe that's what the mayor meant by counting backwards. So the takeaway from this story is that you really have to be careful with the data types that you're using. It can be really tricky to mix up things like integers and size t types and int at types. And if you use the wrong types, you might leave yourself susceptible to overflow attacks or signed unsigned vulnerabilities. And of course, this article occurred in Florida. OK. So here's another example. You might say the example from earlier where I take the length and I add 2. That seems so contrived. Who would take length and add 2 and cause an integer overflow? But it turns out, here's an attack from 2022. And apparently, the commit that they made to the code repository was this. The code used to look like this, where I took the page size and I subtracted 2. And they swapped it around for reasons that are beyond me. And they instead said, actually, instead of taking page size and subtracting 2, I'm going to take length and add 2. What does length plus 2 remind you of? The exact same attack that we just saw. So this is an example of someone in real life doing the exact same thing that we just showed you in the slides. So that's another example of silly things happening in real life because C is bad at type checking and checking bounds. OK, so to quickly summarize all the things we saw so far, we saw buffer overflows, which is a catch-all term for attackers overwriting parts of memory that they should not be overwriting. And in particular, we saw a really common type of buffer overflow called stack smashing. And that's the one where the attacker overwrites the RIP on the stack, because that's a value that's always on the stack. Any function you call has an RIP, and that address tells you, when I'm done with this function and I'm returning, please go to this address and start executing code. So stack smashing is the attack where you target that register. And by overwriting that register with the address of shellcode that you injected into memory yourself, you can cause shellcode to execute. And we saw that to fix this, you have to go through the C manual and find the secure equivalents of various input-output functions. And we also saw another class of buffer overflow attacks called integer vulnerabilities. They related to integer types and how the same sequence of bits, FFFF, could either be treated as signed or unsigned. The same sequence of bits, if you read it as signed, it could mean a really big number. Or rather, if you read it as unsigned, it could be a really big number. If you read it as signed, it could be a really small number or a negative number. And because of those vulnerabilities, or the vulnerability where you take a large number and you add 2 and it becomes a really small number, you could actually bypass some of the checks that the attacker added or the user added into their code and allow the attacker to overwrite parts of memory that they weren't supposed to. And those are exploiting the fact that the same bits can be interpreted 2 different ways in C code. That's a summary of what we talked about.